Hello students, let's start with central orbits. Introduction. A force whose line of action always passes through a fixed point is called central force, and that fixed point in this definition is called center of force. And the path described by a particle under action of central force is called central orbit. For example, our earth revolving around the sun or moon revolving around the earth. In this case, sun will be the center of force and path which earth describes around the sun will be central orbit. And the force with which earth is revolving around the sun, that force will be central force. Result: a central orbit is always a plane curve. Let this is central orbit. We have to prove the central orbit is in plane. Now what we will prove for this? Let we draw 4 5 lines, or you can say radius vector in this plane. Now to prove that those radius vectors are in this plane, we must have a line or constant vector perpendicular to all those vectors. Say this is say h. So we'll prove this h such that r is perpendicular to randomly choose radius vector r. Now p is a particle which is moving around O under central force in central orbit. Central force means force is directed towards O. Therefore, acceleration is also directed towards O. Acceleration is d square r over dt square. And we can see from figure, acceleration is parallel to radius vector r. Therefore, their cross product will be equal to 0. Now, adding this term a cross a, because it is 0, we have this result. And this, now derivative is 0 means term is constant. Say constant is h. Now consider this term r dot h, and substituting value of h from here, we have scalar triple product where two vectors are same. Therefore, scalar triple product will be equal to 0. So r dot h equal to 0 means they are perpendicular. Now r is here randomly chosen. Means any vector, any radius vector is perpendicular to constant h, which proves the result central orbit is a plane curve. Differential equation of central orbit in polar form. Again, let P be particle moving around O under central force F, having radius vector r and angle theta. Now since particle is moving only under this force which is along radius, so there is only radial acceleration, no transverse acceleration, so this will be 0. The equation of motion along radius vector is mass into radial acceleration is equal to mass into force. Negative sign is here because force is acceleration is in the direction of r decreasing. Similarly, what will be equation perpendicular to radius vector? It will be mass into transverse acceleration is equal to 0. So here we have this derivative equal to 0 means this term is equal to constant. Say again h. Now let us consider r is equal to 1 by u. We will consider this r equal to 1 by u in all the numericals, in all the problems. Differentiating this, we have first derivative and second derivative of r with respect to t. Now we'll use equation number 1. So substituting value of this from equation number 3 and this double derivative in equation number 1, we will get this result. And after simplifying, we have this one, which is differential equation in polar form. D square u over d theta square plus u is equal to f over h square u square. And this differential equation is very important for our problems, numerical problems. First problem, particle is moving under central force in a circle, describes a circle. So what is force? Force is attractive, and we have to prove that force is attractive and inversely proportional to fifth power of distance. That means we have to find here law of force. Orbit is given and we have to find law, under which law that particle is forming a circle. So what is equation of circle in polar form? R is equal to 2a cos theta. Now again let r is equal to 1 by u. It means u is equal to this one. Differentiating, you will get first derivative and second derivative. Now we have u and second derivative. So we will put these two values in differential equation. This one is differential equation. And after substituting these two values, we will get f is equal to lambda over r5. Means f is directly proportional to 1 over r5, means inversely proportional to fifth power of r. Hence the proof.